This is another video in the series on the KAS IDE software that's used to program our PDMM and PCMM EtherCAT master controllers. In this video, I'm going to go over subprograms, specifically how to create a UDFB, or a user-defined function block. This is a great way to create a section of code that you're going to reuse over and over again, so you don't have to copy and paste or make changes if you want to use it for different axes or different speeds. You can choose which inputs and outputs you want, and the inside code would be reused for as many instances you want to use it in. As an example, I'm going to create a PLS, or programmable limit switch, function block as a new subprogram. Now, you wouldn't have to if you're using the Kollmorgen Automation Suite software, as we do already have a built-in function block for this. If I go under Libraries, under Kollmorgen UDFBs, Motion Common, there is already a PLS subprogram created. Now, everything under the Kollmorgen UDFB section of the function block library are subprograms that application engineers like myself with Kollmorgen have developed over the years. We've just added to the product. If you were to drag and drop these onto your PLC programming environment, they automatically would get added to the subprogram section of the Project Explorer in the KAS IDE software, and our template programs will use a number of them. So you can already double click on some of these and see they were built in Kollmorgen UDFBs, but you can see how they were programmed. You can watch them animate while your program's running, and if you do want to make changes to them, we do have one extra form of protection. You have to right click them and click the Create Unlocked Copy, then a copied version with a slightly different name, starting with U for unlocked, would be added to the subprogram section of the Project Explorer. And if you open up this, then I can make edits or changes to the unlocked version. This is just to help us troubleshoot. We certainly want you to customize all subprograms that we have included, but then if we're looking through your program, we can tell right away by the name change that something may be off of our built-in version. But for now, I'm going to go and make a new subprogram. To do that, you have to right-click the subprogram section of the Project Explorer, and you can either import one that was already created previously, or you can create a new function or new UDFB. The differences between these two is a function will not be instantiated when you add it to your project, meaning it won't create a separate set of variables each time you add a new instance of it in your project. This means that if you call it multiple times, the internal variables will all be shared. So if you want to use this with multiple axes, it will have different positions or have moves inside of them, and you want to be monitoring when a move is done or not, you typically want to make a UDFB, short for user-defined function block, instead. A UDFB, you have the option to create multiple instances of it, each one with different internal variables. So if you want to call it multiple times, have them active all at once, each one can have different sets of internal variables that are keeping track of different positions or moves separately. So when in doubt, create a UDFB, but if you know that for each set of inputs there's only one possible output, you can go ahead and create a function. I'm going to create a new UDFB, and you have the option to pick any of the different IC 61131 programming languages to develop them. I'm going to use structured text, so I'm going to choose ST, and then you can give your new UDFB, your new subprogram, a name. I'm going to call it Joe's PLS. Then you'll see this pop up, and you can define the inputs and outputs you want to use for this subprogram. Note you can come back later and either add or remove them or change the order that they're in, so you don't have to know ahead of time exactly what your inputs and outputs will be, or even the names or order of them. So I'm just going to click OK and show you that if you want, you can always go find your subprogram in the Project Explorer, right click, choose in and out parameters, in order for that pop-up window to come back if you want to make changes. To start specifying your inputs or outputs, you can simply double click next to the ... or highlight it, click the edit button, and you can declare new variables. I'm going to start out with a Boolean input just called enable to specify if you actually want the function to execute or not. My next input will be axis ID, so the user can choose which axis, if they have multiple in their program, they want to check the position of. And the variable type for this will not be default Boolean, but it will be a built-in structure called axis ref, which is what we use to specify our servo axes in this product when you're using the PLC Open Motion engine. And then I'm going to add a start position, which will be a long rail variable, and a stop position, also long rail. Long rail is the 64-bit, which is the most precise floating point variable type that we have in the product. We typically use with positions. So in the subprogram, I'm going to have the user specifying a start position and a stop position, and I will look up the current position of the axis they specify, and if the current position is between the start and stop position, I'm going to make an output called inBetween, which is a Boolean variable, be true. If it's outside of those positions, then I will make the output false. So you can always go back and add or change the order, move up, move down at a later time if you decide you want to make changes. But once you click OK, if I go to the dictionary, there now is a new section, the same name as the subprogram, that I expand will show you all those inputs and outputs are created for use when developing your subprogram. You can also add here to have internal variables that are not inputs or outputs, but are just used to help you program your subprogram. So now if I go back to the Project Explorer and double click Joe's PLS, it will open up in the main window, and I have a blank structured text workspace to start programming. So I'm going to first add an if statement for the enable input, and I'm going to leave some space, and else, so if it's not enabled, I'm going to make the in-between output false. The majority of my code will be then in the first part of the if statement, so if enable is true, so if you actually want to enable or run the subprogram, then I'm going to first have to take the axis ID that the user is inputting and find the position of this axis. Inside subprograms, you can use any other function that we have in our library or any other subprogram that you write or import. So we do have a built-in PLC Open function to read the actual position of an axis. So if I drag that out, I can create an instance of this function block, and I'm going to make the enable input to that function block true, so it's always running. I always want to read the position of this axis, and the axis is going to be axis ID, so the same name as the input to this function. Now I'm going to hit Control Space and declare a new or internal variable for actual position, and I'm going to make it long rail. Now it got added automatically to the dictionary under this subprogram because it is an internal variable, and I'm going to assign the position output from this function block and tie it to that internal variable. Now that I know what the position of the axis is, I can compare it to the start and stop positions. So I'm going to have another nested if statement. If actual position is greater than my start position and it is less than the stop position, so those are inputs to the subprogram, then in between is going to be true, else in between is going to be false. Note you may want to add extra checks. If you have a modulo axis, you may have a different case where if you're specifying a start position that's actually greater than stop position, or you're checking over the modulo, you may have to add extra logic, but for the sake of time, I'm just going to ignore that now and assume that this is for a non-modulo axis, or where the position will continue to grow. It won't reset to 0 at a certain value. So let me do a compile to make sure I didn't make any mistakes. Okay, I got a successful compile. Now I could run this program, but just because I developed a subprogram, I now have to add the subprogram somewhere in a normal program to actually run it. So if I go to my programs, I'm going to open the main program, scroll down to the bottom, and I did start with a ladder template, so I developed a subprogram in structured text, but you can still call it in any other regular program, whether it's in ladder or structured text or function block diagram. Insert a new network so I get some room. And now to use your subprogram, you can drag and drop it right from the Project Explorer, and it will let you give a name to the instance. When you drag it out, I'm going to create two instances, one for axis 1, one for axis 2. And note you could have multiple for axis 1 if you want to specify different start and stop positions. But for the second instance, I'll also show you that if you go to the library, all your subprograms will also show up under this project list. So you can get it not only from the Project Explorer, but also you can find your new subprogram also in the function block library section of the KAS IDE. And it's equivalent, dragging and dropping it from either section. So now I'm going to add some coils to the in-between outputs. I'm going to add the just bars right to the enable so that they're always running when they're scanning this ladder. I'm going to pick axis 1 for my first instance, axis 2 for my second instance, and my first axis I'll do between 0 and 100, and my second axis I'll do between 180 and 270. I'm already connected to my controller, so I can just do a compile and download, then start my project. And since I start out at position 0, I am between 0 and 100, but my second axis is not outputting. So let me go to the control panel and enable and start moving these axes. So I enable, I'm going to start running axis 1, the master, and gear in axis 2, so they'll both be moving. If I go back to my main program, I can look at sometimes axis 1 is in between 0 and 100 and the output goes high. Sometimes axis 2 is between 180 and 270 and that output goes high. But if you want to actually look at the code inside, since there are multiple instances declared, and we can only show one example of the subprogram at a time, you can either on the Project Explorer double click on the name of the subprogram, and while your program is running it will let you choose between all of the instances that are declared in your project, and it will start animating that specific instance, so those specific sets of internal variables and inputs that are being fed to them. So since I chose to look at instance 1 and that's tied to axis 1, this position is going to be from axis 1 in my project. Another way to do this is right from the ladder editor or structure text that you added the instances. You can right click them and choose Open UDFB Instance, and it'll automatically jump to your subprogram code and animate that specific one. It's very helpful to be able to choose to animate a specific one when you're troubleshooting your project. So you may want to not only look at the inputs and outputs, but be able to look at the internal variables that you've declared for your subprogram. So this is just a quick example showing you how you can create your own subprograms in order to reuse sections of code over and over, either with multiple axes or different sets of inputs for the same axis. It's easier than if you have to make changes to it. You only have to make changes once in the subprogram section instead of every time you're recalling similar sections of code in your main programs. So thank you, and hopefully this video was helpful, and you can use it to improve your programming in the KAS IDE environment.